Okay, the following is a video answer key to the ratios and proportions challenge problems that were handed out today in class, and hopefully students will be able to get through these and check their answers online in preparation for the assessment tomorrow. Okay, the first one, write 4 different ratios for the following picture. Try to include both part-to-part and part-to-whole ratios, and then write the ratios in their simplest form, if necessary. So I'm going to start off with a part-to-part ratio. I'll just look at the light shapes versus the dark shapes. So if I say the ratio of light figures to dark figures, there's 1, 2, 3, 4, 5, 6 light and 1, 2, 3, 4, 5, 6 dark. And 6 to 6 can be reduced because both of these can be divided by 6, which is basically a 1-to-1 ratio. And a 1-to-1 ratio says that for every light shape, there's one dark shape. So 1 light shape, 1 dark, 1 light, 1 dark, and so on. And you'd see that if I did that, there would be 6 groups, each containing 1 light and 1 dark, and that's where this divided by 6 comes from. Maybe another one I can do is triangles to circles. So I have 1, 2, 3, 4, 5, 6, 7, 8 triangles, and 1, 2, 3, 4 circles. And both of these numbers are divisible by 4. So I'm going to reduce to lowest terms, and that's 2 to 1, which means for every 2 triangles, there's 1 circle. So for every 2 triangles, there's 1 circle. For every 2 triangles, there's 1 circle. For every 2 triangles, there's 1 circle. And for every 2 triangles, there's 1 circle. So these are both part-to-part ratios because I'm only concerning myself with parts of the picture, just the light ones versus just the dark ones, or just the triangles versus just the circles. And so a part-to-whole ratio would look something like this. Light shapes to all shapes. Okay, so a part-to-whole would have to do with basically like a fraction, a part of the picture to every single part of the picture, so the total number of things. In this case, there's 6 light, and there are 12 in total, and that can reduce to 1 over 2, which means that for every 1 light shape, there are 2 dark shapes. Or actually, no, that's wrong. Which means for every 1 light shape, there are 2 shapes in total, which is kind of like this. So for every 1 light shape, there are 2 shapes in total. For every 1 light shape, there are 2 in total, and so on. I could also do triangles to all shapes. So there are 8 triangles, and there are 12 shapes in total. And these can both be divided by 4. So for every 2 triangles, there are 3 shapes. 2 triangles, 3 shapes. 2 triangles, 3 shapes. 2 triangles, 1, 2, 3 shapes. 2 triangles, and 3 shapes. So now I've finished off this question. Just a few things to note here. I do want every ratio to have a definition, so you're telling me what these numbers represent. That 6 represents light, 6 represents dark. I want you to reduce it if necessary, and then also show what you used to reduce it. So what did you divide by in order to reduce it to simplest terms? Okay, question 2. In a school, 5 out of every 9 students are female. If the school's population is somewhere between 500 and 600 students, how many females and males could be attending the school? So there's a few different answers here. I like to set up a chart for these ones. Whenever it involves a total number, so 2 parts and a total, so in this case there's males, females, and the total school population, I like to set up a chart. So 5 out of every 9 students are female, so 5 out of every 9, which would mean that every 4 out of 9 are males. If the school's population is somewhere between this many students, so that would be a total. So I have to figure out a number that can multiply to 9 to get somewhere between 500 and 600. So I know that 9 times 5 is 45, and I know 9 times 6 equals 54, and 9 times 7 equals 63. So if I were to do 9 times 50, it would be 450. 9 times 60, it would be 540, and 9 times 70 is 630. So here's when that works. It's between 500 and 600, so I'm going to say 9 times 60. And I'm going to apply that same operation to these as well to keep my ratios consistent, to keep them as proportions. So 5 times 60 is 300, and 4 times 60 is 240. So therefore, there could be 240 males and 300 females. So that's a way to solve that problem. For question 3, I want you to draw one diagram that shows all 3 of these ratios involved. And in these ones here, you want to think about changing some of the attributes. So in class we discussed you could change shapes, you could change colors, you could do some shading, something like that. So you can add extra things to the shapes to make them a little bit unique. And so in this one here, I always try to look for the largest value and make that my total. So I'm going to make this shape or this diagram with 12 different shapes in it. And 7 of the shapes are going to be special in some way. So I'm going to make maybe 7 circles. 1, 2, 3, 4, 5, 6, 7 circles. And then the other 5 will be something else. Now I have another ratio, 1 to 3 here. So I'm going to maybe do a 1 to 3 ratio. So here's 1, and then I'll do 3 of a different shape. And maybe I'll do a different shape here. So in this case right now I have my 7 to 12 ratio. My 7 to 12 ratio is there's 1, 2, 3, 4, 5, 6, 7 circles. And there's 12 shapes in total. So I got this one. And then for the 1 to 3 ratio, I have 1 square and 3 triangles. So there's 1 of these and 3 of these, so that's my 1 to 3. I guess I could have done stars to triangles too. And then I need a 1 to 2 ratio. And so what I'm going to do here is I'm going to shade half the shapes. Now you don't have to, but that's one of the attributes that I'm going to use here in order to make things a little bit different. So this one still works. It's still 7 circles. It doesn't matter if they're shaded or not because I just said circles generally, not specific shading or not shaded. So now I can say my 1 to 2 ratio is shaded to all shapes. And really there are 6 shaded shapes and 12 shapes in total. And so that's really the same thing because from 1 to 6, I just multiply it by 6, and from 2 to 12, I multiply it by 6, and since I'm multiplying by the same amount, these are equal proportions. So that's one way you can do it. There's lots of different possibilities for this answer.